arithmetic series is formed by adding the terms of an arithmetic sequence. Okay, so we know what an arithmetic sequence looks like. We have a formula for the general term of it. And we know that we talk about it in terms of the first term and the common difference. Arithmetic series, so here's the sequence, and the terms are separated by commas. And in the series, you basically replace the commas with plus signs, right? So you just want to add it up. So what does that add up to? We can find the sum of the terms of an arithmetic series, and we use a notation S sub 1. Okay, so the sum of one term. S sub 2, the sum of two terms, and so on. So S sub 1 is just equal to T1, right? If you're going to add up only one term, just the first term. S sub 2 is T1 plus T2. S sub 3, T1 plus T2 plus T3. And S sub n is T1 plus T2 up to Tn, right? And that's a finite sequence, right? It ends, right? It's got a first term, which is T1. It's got a last term, which is T sub n. So it could be like, add up the first 100 natural numbers, right? What's 1 plus 2 plus 3 plus 4? And so on up to 100. So it has an ending. Okay, so for the arithmetic series, 1 plus 3 plus 5 plus 7. Okay, so what is the sum of one term of this series? 1, right? You're just going to have 1. Two terms, going to be 1 plus 3, which is 3 terms, going to be 1 plus 3 plus 5, which is 9. 4 terms, what's 1 plus 3 plus 7 plus 9? 16. What's S5? Can you see a pattern going on here? Sum of one term is 1, two terms is 4, 3, 9, 4, 16, 5, 25. Yeah, and then n, what's n? Sum of n terms. N squared. So if you just add up the first n odd numbers, you're really just getting the square, n squared, right? So S sub 10 would be 10 squared, or 100. Right? Now, it'd be nice if we could come up with a formula for this, right? So we can come up with a formula for adding up an arithmetic series, so I don't have to either look for this particular pattern, which is only really going to hold for this one series, right? Just 1, 3, 5. It doesn't work if it's 2, 4, 6, 8, 10. So, see teacher, do you want to see the derivation of the formulas?
Sure.
Sure. It's like, yeah. And went to the dentist and they pulled some teeth, so I'll show you. Let's what do we gotta insert a blank page. All right. So there's this story goes that there's this guy named Gauss. Might have heard of him. He was a famous mathematician, scientist back then. Nobody really specialized, right? Math, science, all the same stuff, right? And Gauss, when he was but a small child, 5 years old, 7 years old, or whatever, was in a class. I don't know if I believe that. Did they have classes back then? And was asked, the teacher who needed some time away from the kids said, I want you to add up the first 100 natural numbers, right? So kids, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus and so on, right? It's going to take a while, right? But Gauss thought about this, and he said, okay, so, I want the sum of 100 terms. And then he said, if I were to reverse the series, except he said it in German, right? German, and we don't even know if that's what he said, or even if the story is true, but says, what happens if you reverse the series? And what do we got here? 3 plus 2. And then you just add it up, right? So if we add this up, we've got 2 of these guys, right? Which, by the way, root 10 plus root 10 is 2 root 10, not root 20. Now, some of you are going, ugh. Okay. So S100 plus S100 is 2 S sub 100s, right? We're going to get 2 times the sum. What do we get here? What do we get here? What do we get here? Now, how many of these 101s do we have? We got 100 of them, right? So 2 times the sum of 100 terms is 100 times 101, right? Because we've got 100 terms, and they each add up to 101. So what's S sub 100? Well, it's going to be 100 over 2. Okay, now, and that's pretty easy to multiply to do, right? It means do 0 on the end and get 5. So it's 5,050, right? Now, how long did that take to come up with? Not long. So that's the idea behind this formula, right? Is that if you do reverse the series, you're going to end up with the same sum each time. Okay? And you're going to have n of those sums. Okay? And away we go. And that's what gives the formula, which is on the other page, because I inserted it afterward, gives this formula n over t. Sorry, n over t. Yes, that's a t. T for 2. N over 2 t sub 1 plus t sub n. First term plus last term. Okay. So in this case, first term was 100 or 1, and the last term was 100, gave us 101, and this was 100, so we had 100 over 2, 1 plus 100. Right. So if we go forward to that page, we can see this is n over 2, and this is t sub 1 plus t sub n. Backwards, right? Rearrange the pages later. So you use this formula. Now, if you look at the formulas, what do they have in common? Well, they both have an S sub n, because that's really the objective here, right? Is we got to find S sub n. In order to do that, we need to have n, because that's in both formulas. And I see T1 in both formulas. So the difference here is, in this formula, we have the last term. And in this formula, we don't have the last term, but we know the common difference, right? Now, we should be able to look at any series and figure out the common difference, right? Just take a term, subtract from that the previous term, that gets you the common difference. We know we can find the last term, right? Because we have a formula for t sub n. Okay, so that's a formula. You're going to be given that, right? You were given that the other day. It was on your formula sheet. It didn't matter because you weren't being tested on it, but it's on your formula sheet, right? T sub n. The sum of n terms of an arithmetic sequence. Now, you have to know it's an arithmetic sequence, right? There's different formulas on the formula sheet. We don't say, hey, this is for this and this is for that. You have to know which one applies. And really, if you substitute this in here and add them, you're going to get T1 plus, you're going to get the 2 T1s plus n minus 1 times d, right? So if this formula just gets stuck in there, you get T1 plus T1 plus n minus 1 times d, or 2. That's where the second formula comes from, right? But they're both on your formula sheet, and you just have to figure out, well, when am I going to use this? Well, I'll use this formula when I know the last term, and I'll use this formula when I know the common difference, and regardless, I have to know how many terms there are, and I have to know the first term. Which brings us to our examples. For the arithmetic series, 6 plus 11 plus 16 plus 21 plus, determine the 50th term. So we're trying to find t sub 50, right? So we got to make a distinction when we're doing these problems now. Am I looking for a term, or am I looking for a sum? In this case, we're looking for a term. So we have form. Now, before we even do any formula stuff like that, let's look at this and say, okay, what's T1? 6. What's D? 5. Okay, now at this point, you just sort of pretend there's commas in there and that it's a sequence. So you go 6 plus 5 gives me 11, plus 5 gives me 16, and so on. More formally, you go 11 minus 6 is 5. 16 minus 11 is 5. 21 minus what we've got D is 5. Okay, we don't know an n or anything here, so determine the 50th term. So t sub n, that's what we want to know. T1 is 6. D is 5, N is 50. Okay, so I've got all the information I need. I'm going to write down the formula, pull that off my formula sheet. So T sub N is T1 plus N minus 1 times D. T50 is T1, 6, plus 50 minus 1 times 5. Okay, that's just direct substitution. Remember the secret to math that's handed out earlier, right? Formula, substitution, answer. Got a formula. We've identified all the different parts of the formula, the thing we have to find, and the stuff we know. We substitute that in, and we just work this out. So it's 6 plus 49 times 5, which would be 250, but 5 less than that, but 1 more than that, it's 251. Okay, question. That's yesterday's or last lesson stuff, which I have yet to read. I'll record it and I'll put it up just so we have a complete set of things. Determine the sum of the first 50 terms. Okay, well, we have two sum formulas, right? Now, the obvious one to use at this point is, hey, I know T50, right? So we can use the n over 2 T1 plus Tn formula, right? We'll do that, then we'll do the other one just to show you it doesn't matter. Okay. So here, let's list what we've got. We've got T1 is equal to 6. We know that N is 50. We know that D is 5. We know that T50 is 251. And that S50 is what we want to find. So if I've listed all that information, I then have the choice, right? It's like, well, okay, remember, we need to know N and we need to know T1. Yeah, and then we need one of these guys. We have both, so you could choose your formula. Easy formula would be this. So start off formula, N over 2, T1 plus Tn. Okay, so now we say, what are we doing? We're doing S50. That's 50 over 2, T1, 6, plus T sub N, 251. And we work that out, right? There's a calculator problem at this point. Somebody with a calculator work this out? And here, S50 is 2 times T1 plus 50 minus 1 times D5. And 245, 257. Oh wait, that doesn't make any sense. I missed something. Oh, we got the N over 2. Green mana. That was when the formula is not there. That's why you need a formula. 50 over 2. 25 times 257. And what's the answer? 6425. And 6425. Right. I mean, either way, it's 25 times 257, and how you get the two, so if you know the first, use this, it's easier, right? If you don't know the last term, but you do know the common difference, then use this. It's easier, right? Or do this, and then do this. It's not easier, but it'll get you the answer just the same. If the first term of an arithmetic series is 12, and the last term is T sub 21. Now, I mean, really, that's, okay, either. So I think this has to be a sequence, right? Okay, because if we're talking T21, we're talking, so what do we know? T1 is 12. T21 is 172. N is 21. D, I don't know. And I need the sum, which I don't know. So if I list all the information I have, that helps me determine what formula to use, right? If you do this, you're going to be taking physics. I know there's a lot of motion formulas in physics, right? If you just list everything, then you say, oh, well, this is the formula I need, right? Because it's got the stuff, you know, it's the things I want to use are there, and the thing I want to find is there. So here, we say, well, we're not interested in D, so I shouldn't have to find it. So let's just go with S sub n is n over 2 T1 plus Tn. Okay, we want the sum of 21 terms, right? So n is 21. S21 is 21 over 2, 12 plus 172. And you just work that out, right? It's just a calculus. How much? 1932. In the midst of the Great Depression. Cross-curricular. Questions? Determine the sum of the arithmetic series. All right, so we know the first term. We know the last term. We don't know how many terms, but we do know the common difference. What's the common difference? Negative 2, right? So it's like negative 18 minus negative 16, which is negative 18 plus 16. Okay, so I mean, you can think of this right as negative 16 plus negative 18, but you're going to replace the pluses with commas. So it's like negative 16, negative 18, negative. So I'm subtracting 2. Okay, so D is negative 2, and what else is there? We need the sum, S sub n. Okay, so what do we have to find that we don't know besides the sum? We need n, right? Both sum formulas use n. How are we going to figure out n? We're going to use T sub n is T1 plus n. So we're going to go back to the formula for the term in an arithmetic sequence. And we're going to say, okay, well, we know the nth term is negative 284. We know the first term is negative 16. We don't know n. And we know D is negative 2. So, what we're going to do is solve that, right? Which actually, luckily, is reasonably easy, right? We're just going to do what? What first thing you should do? I'm going to solve this. Step 1. Add 16 to both sides, right? Add 16. So what's that become? Negative 268. It's negative 2 times n minus 1. Next step. Divide by negative 2, right? I mean, this is the easy way. You could multiply the negative 2 into there and then, you know, but this is easier. Divide by negative 2. 134 is n minus 1, and so n is 135. Okay, now we've got n. So S sub n, n over 2. Which formula? T1 plus Tn or 2T1 plus T1 plus Tn, right? If you've got Tn, yeah, use it, right? So T1 plus Tn. All right, now we know that n, so I'm doing the sum of 135 times, which would be 135 over 2 times negative 16 plus negative 284. And that's just a calculator issue, so the answer is so it's negative, what was it, 20,250? Okay. Agree, disagree? I don't want to go back in and have to put a thing over YouTube saying, but wait, this is actually. You agree? Good. Okay. Questions about this? Everybody good? Ready to move on? How many of these do we have? There's like 7 of them, right?
Yeah, there's 7.
7, yay, okay. So we're almost halfway. Example 4. Determine the value of n for an arithmetic series if t sub 1 is 16, t sub n is negative 35, and s sub n is negative 171. Okay, so I don't really know where to start here, but let's just list what we have. At the risk of being repetitive, I guess. So t1 is 16, tn is negative 35, s sub n is negative 171. We don't know n. We don't know d. Right? And those are all the possible variables there are, right? So from that, we now have to decide, okay, well, we've got three formulas that we can use, right? We've got the t sub n is t1 plus n minus 1 times d. That's the sequence formula. We've got s sub n is n over 2, t1 plus tn, etc., etc. So, which formula are we going to use? So the first one for the sum, right? S sub n is n over 2 t1 plus tn. Because if we look at this, okay, I got t1, I got tn, I got s sub n, right? And in that formula then, the only thing that's missing, so s sub n is n over 2 t1 plus tn. If we fill that in, the only thing we don't know is n. And if you have one equation, you can only solve for one unknown. If I throw it into the other formula with the n and the d, I have two unknowns. So I can't do that. All right, so negative 171 is equal to n over 2, and we've got 16 plus negative 35. Step 1. Multiply both sides by 2. At the same time, I'm going to add the stuff that's in the brackets, right? Because why not? So this will be, what's 342? Negative 342 is equal to n times negative 19. So we just got to do 342 divided by 19, right? Hope that works out. 18? Beautiful. And then what do we have to do? That's it. We're done, right? Determine the value of n for an arithmetic series. Okay, so list all the information you have. If you're stuck, right? If you just know where to go for them, remember the four-step problem-solving method: understand, plan, do, and look back. What are they giving me? Got T1, I got Tn, I've got S sub n. What's the plan? Well, let me list all of these things, and I've got three formulas for arithmetic series available. Which one of them am I going to use? Well, so it's question, what do I have to find? This is what I have to solve for, right? I don't need that. This is the information I have. I've got a formula that involves those four quantities. I'll plug everything in. We'll work it out. Determine the first term of an arithmetic series if D is 12 and S10 is 360. First term, okay. T1. We don't know, but we have to find out. We don't want to cross that out. What else do we know? Well, we know D is 12. What's N? 10. S sub N, or S10, is 360. And what else is left here? T sub N. Equals question. Okay, this is the one we have to find. We don't really care about T sub N, right? So if I can get away without using it, then I will. Can we? Yeah, we got a formula, right? What is it? S sub N is N over 2, 2T1 plus N minus 1 times D. Okay, so do yourself a favor. Be very, I don't know what the word is. Be very deliberate about doing this. That's not really the word, but it'll stand in for the word. You know, so write out the formula, right? And then substitute into the formula. Like, show all of your work. Show what you're doing. Keep it somewhat organized. So if I'm looking at it, I can follow your line of reasoning. which implies that there is a line of reasoning that you are following, right? Which if you're not, just write down, I'm just sticking random stuff down here, hoping that something will stick. Okay, so you show the formula, right? So we've listed all the variables and I've shown the formula, right? And I know everything. I know S sub n is 360. I know n is 10, and I've got a 2. I've got 2 times t1, which I don't know, plus I know n is 10, and I know d is 12. So I'm just going to throw everything in there. All right. So 360 is equal to 5. 2t1 plus, okay, 10 minus 1 is 9. 9 times 12 is, like 10 times 12 minus 12 is 108. This was easier to do using the distributive law, right? We got 120 minus 12 as opposed to going 9, whatever. Okay, step 1, solving. What do we do? Divide both sides by 5, right? Okay, so 360 divided by 5 is what, 72? Yes, 72. Don't be afraid to use a calculator. Next step, subtract 108, so what's that going to be? 36, negative 36. And finally, T1 is negative 18. Okay, remember 4-step problem solving method? The last step is look back, right? Is this reasonable? Hey, I found that n was 7.5. That's not reasonable, right? N is a whole number, right? It's a number of terms, so n has to be a whole number. You get an expression involving n and there's a quadratic, you know it's going to factor, right? It has to. You can't get a 0.5 or a root 7 or something. And then term of the first term of the arithmetic sequence series if d, I mean you could plug back in, if you wanted to check this, right, instead of just handing it in earlier or something, you could go S10, like you could work it out, you could just plug it back into the formula and make sure it worked, right? Just throw that into your calculator, see if that works. If, in an arithmetic series, S sub n is n squared plus 2n. Determine the first 4 terms of the series. Okay? All right, so this is really just a substitution, right? They're giving us a formula here. Hey, here's a formula for the sum. So S1 is equal to what? Remember the secret, it's formula, substitution. So what am I substituting? 1 squared, right? So everywhere we see an n, we're going to put a 1. Plus 2 times 1, which is 1, plus 2, which is 3. Okay, I'm just going to work my way across the board because we have to do S2, S3, S4. Right, and same deal, right? So S sub 2, well, you should be able to work these out, so do that. Okay, so you're substituting in I'm going to extend this question too. Right? We'll just ask a little something more about it. We can do more than that. So what's the sequence that would give me this? Go look for the right S word. The sequence. So we know the first term is 3. What's the second term? 8 minus 3 is 5, right? So the second term is, what do I add to 3 to get 8? I'm going to add 5. What do I add to 8 to get 15? What do I add to 15 to get 24? So there's your sequence, right? 3, 7, 5, 9. Okay, now from that, then you can figure out, well, what's D? Well, D is 2. What's T1? T1 is 3. What's T sub n? I could come up with a formula if I wanted to, but I don't right now. But, you know, if you want to figure out what's the sequence, right, you just say, what do I do to get from 15 to 24? I add the next term, right? So if I've got the sum of 3, how do you get the sum of 4? The sum of 4 is the sum of 3 plus T4, right? So I'm adding 9. That's T sub 4. Lastly, oh, there's an A. Is there a B? Okay. Fire, police, ambulance?
Fire.
Yeah, fire. See the red truck. The sum of the first two terms of an arithmetic series is 13, and the sum of the first four terms is 46. Determine the first four terms of the series. Okay, the sum of the first two terms, the sum of the first four terms is 46. Determine the first four terms of the series. I was wondering if they mean sequence when they ask that. So we kind of did both, but. All right, so how are we going to do this? So we're going to find T1 would be helpful, right? And D would be helpful, because that would allow us to then. Okay, can we do this? Well, we got formulas, right? So let's just write down the formula for the sum. S sub n is equal to, so we either have n over 2 T1 plus T sub n, or n over 2 plus, or n over 2 2T1 plus n minus 1 times D. Okay, now, which one do we think is be more helpful if we knew D than if we knew T sub n, right? We know the common difference, so let's try that formula. So n over 2 2T1 Okay, so what do we got? Well, we just have S4, right? S4. So we could write down, all right, I know that 46 is equal to 4 over 2 2T1 plus 4 minus 1 times B. All right, so we've got an equation with two unknowns. But we also know that S sub 2, 13, is equal to 2 over 2, 2T1 plus 2 minus 1 times D. And we say, but so we have two equations and two unknowns. We can solve this because we can solve a system of equations. Okay? And then once we've got T1 and D, then, everything just falls from there. So let's just simplify what we've got here. So 46 is equal to 2 times 2T1 plus 3D. So we can divide out that 2, right? Get 23 is 2T1 plus 3D. So, okay, there's an equation to work from. And here we got 13 is 1. Well, so just 2T1 plus D. So there's another equation. All right, you could solve by substitution or elimination. What do you want to do? Elimination. They both have a 2T1. So elimination sort of stands out. So we'll say, all right, so we got 23 is equal to 2. Well, let's reverse things a bit. Let's go 2T1 plus 3D equals 23. And 2T1 plus D is equal to 13. Okay, so I subtract 2T1 minus 2T1, 0. 3D minus D, 2D is equal to, and D is equal to, and T1 is equal to, no, 4. Okay, probably work that out, right? So 2T1 is plus D, 2T1 plus D is 13, 2T1 plus 5 is 13, 2t1 is 8, t1 is 4. Okay, is that it? We're done. We got t1 and d. Is it? We answered the question? No. What's the question? Question, what's the first 4 terms in the series?
4, 9.
Okay, so we know, all right, what's the first term? Well, we know t1 is 4, right? So the sequence is 4. We know the common difference is 5, right? So we've got 4 plus 5 is 9, and then 14, and then 19. Okay, so then the series S1 is 4, S2 is 13, S3 is 27, and S4 is 46. Which very luckily S2 and S4 wasn't. There's no luck involved, but S2 and S4 are our checks, right? Yes, you got the right thing. So we don't have to look back. We can say, well, we look back and we say, yeah, I got S2 and S4. They came out as 13 and 46. We've done this question correctly. And it nicely tied 2 units together, right? A little bit of using the formula in sequences and series. And there's also solving a system of equations. Relatively simple one, right? You know, we're not there to beat you up too badly. And if this happens, you know you're always going to have a 2t1, right? That's common. As long as I can get rid of whatever number's in front here. You know, problem would be they give us S5, and then this is 2.5, and then, you know. But we can still solve the system, right? You'd still be able to solve the system. It'd just be a little bit more difficult. Okay, questions on that? So list the information you have, figure out what you have. You have 3 formulas available to you for arithmetic sequences and series. Which one am I going to do? Oh, wait, we still have to do B. Determine the sum of the first 50 terms of the series. Okay, so S50 is what we want. N is 50. T1 is 4. And D is 5. And T50 is who knows or who cares. Okay, so all we do is just plug that in. S sub n, n over 2. We got the T1 and the D1. The T1 and the D1. Every time you do something, write out the formula. It will help you in that when you go to write it out again for the, you know, nth time on a quiz or a test, and you're looking at it, because you should be looking at the formula on your formula sheet. Don't go by memory. But, you know, it'll just help you out. So S50 is 50 over 2. 2 times 4 plus 50 minus 1 times 5. So 25, and we've got 8 plus 49 times 5 is 50 times 5 is 250, 245. And it's just math. It's just arithmetic. What's the answer? 6,825. 6,000. 3. My hearing is gone. I swear. Well, at least you got this all in. And